The rocket stove, developed by Dr. Larry Winiarski, is an improved cook stove designed to dramatically reduce the amount of fuel necessary to cook a meal compared to a traditional 3-stone fire. This short instructional video gives step-by-step instructions for building a small rocket stove designed for cooking with a single pot. Making insulative refractory brick is also covered here in this video. The rocket stove uses an insulated rocket elbow combustion chamber to increase combustion efficiency and reduce smoke and harmful emissions such as carbon monoxide and particulate matter. The fuel wood is placed on a shelf inside the horizontal part of the rocket elbow. In this configuration, only the ends of the wood are burnt. By only allowing combustion to occur in a relatively small insulated space, most of the energy stored in the fuel wood is converted to heat. That heat is then transferred directly to the cookpot. Cold primary air enters from below the fuel shelf and is preheated as it enters the vertical part of the elbow, where it mixes with fuel and flame, creating a powerful draft. The hot flue gases then immediately contact the bottom of the cookpot as they leave the combustion chamber. The use of a pot skirt can greatly increase the fuel efficiency of a stove by forcing the hot gases to travel up the sides of the pot as well as the bottom before leaving the stove. Rocket stoves can be constructed in many different ways from different types of materials. To build this type of single-pot rocket stove, you will need sheet metal or a 5-liter can for the stove body, clay, water, sawdust, and a wooden mold to make refractory bricks for the combustion chamber, a small amount of vermiculite or perlite, and cement to make a lightweight fill that will be used to secure the combustion chamber in the stove body. The lightweight insulative bricks that make up the combustion chamber in the rocket stove are made from water, clay, and sawdust. The sawdust will burn out when the bricks are fired in a kiln, leaving tiny air holes that increase the insulative value of the brick. A combustion chamber made from insulative lightweight brick has better draft and higher combustion temperatures, which decreases emissions made from burning biomass. Mix the clay and sawdust first. Knead the sawdust into the clay. When the clay and sawdust are very well mixed, add water and mix the ingredients again. Recipes will need to be fine-tuned for the type of clay and the consistency of the sawdust you are using. One that has worked well is 500 grams of dry sawdust, 900 grams of moist clay, and 1200 grams of water. The bricks should be fired at around 1000 degrees Celsius, a normal temperature for brick making. The insulative bricks should be about 0.6 grams per cubic centimeter. At that density, they will float in water. Make wooden or metal molds and fill them with the clay-sawdust mixture. Wet the mold to help the bricks slip out of the bottom. Fill the mold, pushing the clay into all corners. A block of wood can then be used to push the brick out of the mold. The wood can be removed later when the brick has hardened. Here is the fired brick. It has reduced in size as it was dried and fired. After a bit of experimentation, lightweight, durable bricks can be easily made. The combustion chamber is made with one shorter, heavy brick in the back, which resists abrasion from the sticks of wood being pushed into it. The other bricks are placed around the heavy brick in back. 3 courses of brick make the combustion chamber. This creates an insulated space above the fire to help the smoke, air, and fire to mix together so that the smoke is burnt up and the pollution that is harmful to human health is decreased. A cylinder made from sheet metal surrounds the combustion chamber. A square hole is cut to line up with the fuel entrance in the combustion chamber. Slip the cylinder over the combustion chamber. Place a brick temporarily in the fuel entrance. This will allow you to fill the stove with a lightweight cement mixture. Mix the cement with perlite or vermiculite and pack it into the space between the outside of the combustion chamber and the metal stove body. The concrete secures the combustion chamber in place. 3 pieces of steel serve as pot supports. They slip into 6 holes drilled into the stove body. The pot sets down onto the steel in the cylinder of sheet metal, leaving a 12 millimeter gap that forces the flame to touch the sides as well as the bottom of the pot. This technique significantly reduces the amount of fuel needed for cooking. To greater increase the fuel efficiency of this stove, a pot skirt can be used. A pot skirt is simply another piece of sheet metal that is placed around the sides of the pot, leaving a 12 millimeter gap for the hot flue gases to pass through. Forcing the hot gases to flow against the side of the pot allows for more heat to be transferred into the pot, reducing the amount of fuel needed to cook. This design for a rocket stove can be easily adapted to your locale by using materials that are inexpensive and locally available. Some things to remember while designing your own rocket stove are: the combustion chamber should be made from a lightweight, insulative material. Using a grate to hold the fuel off of the bottom of the combustion chamber will help to create a strong, lively draft. Allowing the pot to sit into the stove and/or using a pot skirt will greatly increase heat transfer efficiency and help to decrease fuel consumption. More information about the rocket stove and other designs for fuel-efficient cook stoves can be found on Aprovecho's website at www.aprovecho.org.